said, I told you to turn the examinations in. Elevator doors closed, up he goes, and she stood there with a test in her hand. That was harsh. So better to have it here, happen here than in college when you're paying for it. He was a different sort. You don't ever need to deal with a guy like him. Hopefully you never will. Although he's a good teacher. He was just pretty straightforward.
Is he the one who passed the test back?
Yeah. From high up, that's to worst. The longer you sat, the worse your test score was. Yeah, he had all of the tests when he graded them. He had them in order from the highest to the lowest score, and that's how he handed it back to you. And you had to walk down and go get it. In a big, huge lecture hall, you know, the size of your gymnasium.
You should do it like that.
Yeah, right. So then, after he did that, I wrote on the board ahead of class before he walked in, Dr. Gunji, could you please shuffle the examinations before you return them? And this is what he does. He reads that. He goes, cuts them. Starts reading them off. He was something. Okay, so 5, 6. We gotta get through this. This is going to be auxiliary figures and uniqueness. I don't know that it's going to be a whole lot of new, but it might be a different way of looking at things.
Will we go over the way you're looking at it at all before then, like today?
I'm sorry, what?
Did you just say like it'll be a different way of looking at it
Yeah,
for the test?
no, this lesson is a different way of looking at things that you probably have assumed already or intuitively will make sense to you. So, first of all, this idea of uniqueness. If something's unique, what does that mean?
It's special.
Special, more than special.
It's different.
Different? It's not like other things, so it's
One of a kind.
one of a kind, yeah. So you are each unique. One. There's only one that exists. That's what uniqueness is about. So if we considered a segment like that right there. So this is segment AB. And if I was asking you about the midpoint of that segment, is that a unique location? Is there only one location, which is the midpoint?
Yep.
Yeah, you don't have two midpoints, do you? That wouldn't make sense. So the midpoint is unique. How about if you did a bisector of that? What if you did a bisector? Is that unique or not?
Yeah.
Where would the bisector go through? Maybe here, right? So is that a bisector? Did I cut it in half? Bisect. Okay. Is this a bisector? Oh, so is the bisector unique? No, it's not unique. How about this? Perpendicular bisector, is that unique?
Yeah.
Why? You're right. Why though?
It's one of a kind.
It's one of a kind. What's true about a perpendicular bisector? It goes through the midpoint. It's a 90-degree angle. So is a 90-degree angle, is that measurement unique? Is there only one way to look at something and say it's 90 degrees? I mean, you could have different orientation, yes. But is a 90 a 90?
Yeah.
Period. There's no two ways of drawing. I can't say, well, there's a 90 and this is a 90. I can't say that. A 90 is going to be a 90. So, that's unique. Is that okay? Okay. Now, you guys just did some work where you took 3 points like this, and I'm just going to sketch this out, and you came up with perpendicular bisectors of pairs of points. And when you did that, you came up with this location here. And what was unique about that particular location? So like if I had points A, B, and C, what did this end up being?
Radius of the circle.
That was the center of the circle. So there was a radius, there was a radius, and here was a radius. So what we had is we had only one circle that we could draw in here. And this was the center of it right here. So what ended up happening is when we had 3 points, there was a unique circle. There was only one circle. If you think about it, if you drew a circle that was different than this one, they're not going to fall on that same circle. And at the same time, if you said, well, I'm going to call that the center of the circle and change the radius, then the points aren't going to be on the circle either. So they come up with a theorem from that work, and it says there is exactly one circle, a unique circle, through 3 given non-collinear points. That's the unique circle theorem. So maybe remember that one in your theorems and postulates pages, the unique circle theorem. Okay, and then I'm gonna move on from there. Auxiliary figures. So, what's an auxiliary figure? An auxiliary figure is something that you add to a drawing to help you understand the drawing better. You know, it's an imaginary additional figure, but it allows us to use different definitions and theorems and things like that. So, if you had a parallelogram, or a quadrilateral like this, and you were trying to find the bisector of angle B. If you drew this line and connected to that point, and look at my drawing and consider it to be accurate, I'm not trying to make it a perfect height, but look at that. Did this additional line that I drew in here, did that bisect angle B? Really? Here, let me twist this a little bit. I really meant for C to be up here. No, I didn't. I meant for C to be down here. Now when I draw that in, does it bisect? Does it cut in half angle B? No, it doesn't. If I had a rectangle like this, could I go across like that and say that this diagonal, which is an auxiliary figure, cut this 90 degrees in half? Really? Here's a rectangle. Does that cut this 90-degree angle into 245s? No, I don't think so. But if I had a square like this, and assume that this is a perfect square, now maybe that auxiliary figure does cut it in half, doesn't it? So sometimes we can draw things in and they're helpful, other times they might not be helpful, at least they might not be helpful initially. We might have to take into account different things. Here's one that is helpful. First off, if I was to draw a triangle like this, what is the sum of the interior angles? What do they add up to? This should come from a previous class.
Of a triangle or the
Of the inside of a triangle,
180?
these should add up to 180 degrees. Recall that?
Yeah.
Okay. And actually, let me do this. I'm going to draw a different triangle in this one. How about if I use a triangle so it looks like a triangle when I'm done? There you go. Okay. So the interior angle should add up to 180, right? Long ago, I had you tear the corners off of a piece of paper, and then you lined them all up, and it added up to 180 degrees. I don't know if you remember doing that. But here's another thing we did do. We've got a side right here. And what I'm going to do is I'm going to take this side, and I'm going to draw an auxiliary figure. I'm going to draw another line that's parallel to this, parallel to BC. So what I'm going to do is I'm going to put it up top. So we add in this, and we're going to say that it's parallel to this side of the triangle. And let's just say for kicks that this is 30 degrees. And if this was 90 degrees, because I used a 30, 60, 90 triangle, let's say we have those two pieces of information. What does this third angle have to be? Should be 60, right? Well, can we prove that? Maybe prove it backwards in a way. So let's do something here. We have a line down here across the bottom. We have a line up here, they're parallel. And then what if we took a look at this side of the triangle? And if you just look at these two parallel lines in that one side of the triangle, what do you have there? Yeah, I'll draw a little picture of that with something like this. What's this an example of? Parallel lines cut by a,
Perpendicular bisector?
well, it's probably not perpendicular, it might be, but it's a transversal. Somebody said over here. So we've got a transversal, so you think of one side of the triangle as a transversal. And then if you start looking, that 60 degrees is like this angle right here. Where else can you find 60 degrees?
Vertical. Yeah.
Vertical, so that'd be out here. How about along that line that I drew across the top? If this is 60, where else is 60?
To the left or right?
On the other side?
Where? On the other side of the transversal, but up here.
Yeah.
So no one was showing me with her head. One of those things. It is over there. Okay. So now let's look at the other side of the triangle that we've drawn here. And think of this as a transversal. Yeah, it happens to be 90 degrees, but it doesn't have to be 90 degrees. If this is 90, and we use the same idea as going to the other side of the transversal, this is 90. So do all three of these angles add up to what a straight angle is?
Yeah.
And what's a straight angle? How many degrees?
180.
It's 180. So what we've done is we've used this idea of, what is that called? Parallel lines and a transversal. These two angles are
Vertical angles.
alternate interior. These are alternate interior angles. These two are alternate interior angles. I mean, it makes sense, this adds up to 90. If you do this with a different triangle like they do in the textbook, you'll see that those two will add up to this side as well. So that's using auxiliary figures to prove that any and all triangles have to add up to 180 degrees on the inside. So you can do that with any measure. You know, if I was going to change this to let's say this was a 50, then this one would have to be 100, and then this would have to be 100, and this would have to be 50, again because of the alternate interior. And see, everything still adds up. So we'll work with all triangles.
But 50 plus 30 doesn't equal 100 there.
Well, 50 and 30?
Didn't you say that the two sides would add up to that other one? Or is that just in that example?
Well, if I change that from 60 to 50, this would have to be 50, right?
Yeah.
Okay, this is still 30.
Yeah.
You would have to draw another auxiliary figure to figure out where a 30 is. See, these two are 100 because they're alternate interiors. These two are 50 because they're alternate interiors. These two here add up to 130, so if you called this the alternate interior, that would also be 130. And 130 plus 50 is 180, so that works.
Oh,
You see, we could keep going with this, couldn't we?
yeah. That's pretty cool.
Yeah, it is. Yeah, see, you can keep building. You put more figures on here if you wanted. I mean, you could have something parallel to this side if you drew it in. And then you could come up with more alternate interiors coming off of this 50 and that 30. You could do this all through Christmas break if you wanted to, right? Yeah, it'd work out. Okay. Yeah. Let's let that go. Go from here. You're better off working on some of these things.
Thank you.
You're welcome. Right, we'll see how that all goes. Maybe a little bit of wait and see which we. 5-5. Yeah, 5-5 when you're done, do you know? You think you did it? There's a lesson mastered.
No, I was actually like to shoot it.
Yes.